trying to help you guys decipher what's going on in the textbook. So this is the second part of inference for introduction to inference, and it follows right on the heels of what we did with significance test or hypothesis test in Chapter 7 or this last week. So hopefully this will help tie it together and make more sense to you. So I kind of thought, based on some conversations I had with people, I still realize there's a little bit of what word am I looking for? A little bit of uncertainty about what these symbols all mean. So when you have this funny looking U, that's mu, it's pronounced, it's a Greek letter mu, M-U, and that stands for the population mean and the population average. With confidence intervals, we assume that we don't know what that is. With significance tests, we try to see if it's different from some stated value. X bar is the sample mean. If we're dealing with proportions, this textbook uses a capital P to stand for a population proportion. And then p hat's how we say that, is the sample proportion. That comes from a sample. Oh, N is the sample size. E is the new letter for this chapter, and that stands for the margin of error, which you can add or subtract. And I'm sure you've seen these already with it being a presidential election year. I'm recording this in 2016. So we'll see what the fall brings. So I'm going to try to link what we're going to learn this week to what we worked on last week. And here's a problem out of Chapter 7, one of the odd exercises out of Chapter 7. And it's a significance test. They're telling us to test the 5% level. This is about proportions because they're telling us that 23% of all crimes had identity theft, and in Arkansas they had that many complaints out of that for identity theft out of that many total complaints total. So we're trying to prove or show that Arkansas has a higher proportion of identity theft than this national figure. So I used the applet to run a significance test, and notice HO was a greater than, so I made it a right tail test. So the applet told me I had a test statistics to 32.2, which is huge, and the p-value is practically 0. The chance of getting a sample of that many crimes where that higher percentage of those crimes are dealt with identity theft almost won't happen if that's the true center. So we're going to reject HO. It looks like the sample data supports the claim that the percentage of crimes in Arkansas that deal with identity theft is higher than that national figure. Now, how does that relate to the confidence interval? Well, I let the applet calculate a confidence interval for me. I actually let it calculate a 90% confidence interval, and that's what it told me. And we'll talk about what all those numbers mean here in a minute. But what I do want you to notice is how this is as low as using the sample result, this is as low as the percentage could be, or proportion could be, and this is as high as it could be at the 90% level. Now, there's a 10% chance, 5% in either side, that I could have missed the true proportion. But this is our best guess on what the true proportion of crimes in Arkansas are that deal with identity theft. Notice that this 0.23 is not anywhere inside that interval. So that kind of verifies, that's a way to verify your significance test. I mean, we said, nope, it's not going to happen. That's a too low a p-value. And here's another confirmation. So what are some pieces here that we deal with? Now, we're going to pretend now for the confidence interval, you don't know what P is. You don't know that population proportion. This 0.23 figure is no longer available to us, so we don't know what it is. So we're just going to look at what the sample gave us. We took that sample of 3482 crimes, and almost 46% of them dealt with identity theft. So to start throwing some confidence interval language in it, that sample proportion is our point estimate. That's our estimate of the true proportion of crimes in Arkansas that deal with identity theft. Now we know that for the central limit theorem tells us, okay, so we went out and did this one sample. We got 0.4598. We know if we went out and did a different sample of 482 crimes, counted up how many of those crimes dealt with identity theft, we'd probably get a different percentage or a different p-hat. And those, what happens is those just fall in a pattern, in a normal curve pattern, around the true proportion, whatever that proportion is. And so we know because it falls in a normal curve pattern, we can apply some of these inferential techniques. So this is our point estimate. Now, how did they get these numbers? Well, what they did is they took our p-hat and they found some margin of error with it based on the 90% confidence interval. Now, we don't know what that margin of error is, and that's one thing we're going to find here. In fact, we can do it with a formula. I don't really want to go to the formula with this yet. I can. There's plenty of videos out there. I've made plenty of videos about the formula. So let's just talk about this, because this is what my open math's going to ask you to do. Suppose they want me to find they just gave me this. Suppose they wanted me to find p-hat. We know what it is, so that's a way that we can check it. So p-hat's in the middle of this interval. And it's symmetric. It's the same size, same on each side. So if we could find the middle of that interval, that would be p-hat. So how do we find the middle number with 2? Well, it's basically finding the mean. So we're going to take 0.4459 and add 0.4732. 37. Add those numbers together, divide by 2, you'll get that. So that's how you can find p-hat, the sample proportion, if they just give you this interval notation. How do we find the margin of error? Well, we know, and here's what I want you to think about. If I have this, and I want to find the lower bound, if I want to find the lower bound of that, I'm just going to take my p-hat and subtract my margin of error. And if I want to find the upper bound, I'm going to take p-hat and add my margin of error. And of course, using that inequality notation, we're going to say the true proportion of crimes in this case is in between those two numbers. Now, if I want to find I know p-hat, if I want to find the margin of error, isn't this interval 2 margin of errors wide? I subtracted it down here, and I added it up here. So that's 2 margin of errors wide. So if I can find out how far apart these numbers are, divide them by 2, that will tell me the margin of error. So let me move this up a little bit here if it'll let me. So I'm going to subtract 0.4737 minus 0.4559, and I'm going to get some number, and I'm actually going to calculate that here since I don't have that answer right handy. 0.4737 minus 0.4459 that's 0.0278. Now that's the 2 margin of errors wide. Now I'm going to divide that by 2, and that's going to be my margin of error. So I'm getting 0.0139 for my margin of error. So I could write that in this form now. I could write this as, let's see here. Plus or minus 0.0139, and I could write my margin of my point estimate, or the p-hat number here. What was that? 0.45. No, I don't remember. I'm just going to let me scroll up and find it. 0.4598. So this is written in that form p hat plus or minus e. So I added them, divided by 2 to get the p hat number. I subtracted them and divided by 2 to get the margin of error. Okay, and I think that's all I'm going to ask you right now. I mean, maybe other than interpreting the result, but we'll do some more to show you that. So this is another proportion problem. I'm seeing that 36 children out of 150, 36 accidents out of 150 involved children under 6 years of age. So, and then I didn't edit that out. I broke this out a little bit. So what's the point estimate? Well, the point estimate is our p-hat value. So 36 divided by 150. If you crunch that on your calculator, just because I've done this 3 times now, I know that the probability is 0.24. Or not the probability, the p-hat, the sample proportion is 24, or about 24% of all accidents involve children under all accidents requiring treatment in an emergency room involve children under age 6. Okay, so then they're going to ask us in my open math to find a bunch of this stuff. Margin of error, confidence interval, etc., etc. So what I did earlier is I actually ran this out on that Rossman Chance applet, and I let it give me an answer, and let me go get that to show it to you. The applet gave me. Notice I put in the 150 and 36, got the 0.24, and I had it calculated 90% confidence interval for me. So that's the actual interval. Could be as low as 0.18, 26, as high as 0.29. And now to put this in context, or real world, as she says, and the author says, we're estimating, or we're 95% confident that the 90% confident the true proportion of accidents that involve children, trips to the emergency room that involve children under the age of 6 is between 0.8 or 18.3% to 29.7%, if you want to use percentages. Okay, so that's what it all means. Now we've got to break down the pieces. Just like I did before, actually, let's see, what did I have to do here? Let's find the margin of error. So if you think back to that example I just did a minute ago, in order to find the margin of error, we're going to take the upper bound and the lower bound, subtract those, and then divide by 2, because that's 2 margin of errors wide. So let's see. 0.2974 minus 0.11826. That gave me 0.1148. Now I'm going to cut that in half. So my margin of error is 0.0574. If I wanted to write that with that inequality symbol, right here, what I'm going to do is I'm going to write my 0.24, whoops, so there's the margin of error. What did I just say? 0.0574. Now if I wanted to write it with this inequality symbol form, I'd write 0.24 as p-hat minus 0.0574, that's how they got the lower bound, is less than, I'm just noticing I should have changed this to p. Sorry about that. P is less than or equal to 0.24 plus 0.0574. Okay, so p-hat minus e, p-hat plus e, and that's my estimate. The true proportion should be somewhere in between there. So I hope this helps you answer those my open math questions about this. I just realized that some of you might want to do this by hand with a formula. So let's set that up. So I've got a 90% confidence interval. That means I have to use z equals 1.645. P-hat was 0.24. And I know 1 minus p-hat is going to be what? 0.76. So to find the margin of error by hand, I'm going to take my 1.645 times the square root of 0.24 times 0.76 divided by the sample size was what, 150? So we'll calculate that, and we should get that same number, that same 0.057 number. So now we're into sample means here, and the one reason I know this is a sample mean and not a proportion, they're talking to me about average percentages. Now in this problem they just gave me data. They didn't tell me X bar and S. You'll see in a couple of the examples I've got later on that that's what they're going to do. They'll give me X bar and S. I won't have to calculate the data. The book has you check and make sure that this is a normal distribution. We're pretty sure this is a random sample. They don't tell us that, do they? I guess we're going to have to assume that this is a random sample. The other thing that I'm counting, though, is I see that I've got 2, 4, 6, 8. So 6, let's see, 1, 2, 3, 4, 5. There's 40. There's 47. I'm counting n equals 47. Is that what the output told me? Yeah, there's 47 pieces of data. So as long as we're over 30, we can use these techniques, right? We can use these normal, the central limit theorem applies. So even if it's a confidence interval, that works. So again, this was a problem from last week in chapter 7. So they're telling us to test to see if the average percentage of women in 2009 was higher than it was in 1999. So I ran that, I pasted that data in. I let it calculate the mean and the standard deviation for the sample. Then I let the applet, I set up the HO and H1. I ran the test. I found a very small p-value. There's the test statistic, which is a t-score. So it looks like this average, this sample shows that the sample evidence to support their rejection of the claim that, or to support the claim that the 2009 average is higher than the 1999 average. And then I let the applet calculate a 90% confidence interval for me. And notice that doesn't contain the 80.81, so that's the further confirmation. So just so you're connecting it. Now, what's the point estimate going to be here? Well, the point estimate is going to be your sample result. So that's our point estimate, the 90.95. What's the units on this? Percentages, right? Percentages. Now, if we wanted to find the margin of error, remember how this was two margin of errors wide with proportions? That's true for this too. So I'm going to take the 93.0254 minus the 88.8746, subtract those, divide by 2, and that'll be my margin of error. So 93.0254 minus 88.8746. That gave me a difference of 4.1508. I'm going to cut that in half. So my margin of error for this sample is 2.0754, or for this confidence interval. And if you needed to write this in interval notation, inequality notation, I'm going to take my sample mean of, what was it? It was, it was 90.95. So 90.95 minus my margin of error is less than or equal to, now this is a mu, this is an average you're working with, a sample average, sample mean. And I'm going to write 90.95 plus the 2.0754. You get the idea, I'm running out of room. So, similar techniques, just dealing with means. So here's a problem about minivans. I'm seeing the average weight of 40 vans, that's N, was 450 pounds, 4,150 pounds, that's X bar. And there's our S, because this came from the sample. So what's our point estimate? Our point estimate is the X bar. X bar was 4150. That's our estimate for the average weight of all minivans. They want us to find a 99% confidence interval for the true mean. Well, so what I did is I let it calculate it for this situation. Now, notice I did one mean. I don't need data here because they gave me the statistics. So I typed in, I put in the sample size, I put in the sample mean, I put in the standard deviation, I hit calculate, though you don't need to do that part of it. I checked confidence interval, I checked a 99, I've changed it to 99, and there's the actual confidence interval. So then what do they want us to do? So there's B. Find the margin of error. So the margin of error, remember this is 2 margin of errors wide, so 4355.5162 minus 3944.4838. Subtract them, divide by 2, you get your margin of error. That's a difference of 411,033. Now I'm going to cut it in half. So 205.5165. So that's my margin of error. What else did they want? Oh, then we got to write it in interval form or inequality form. So the mean was, let's see, I don't remember. 4150. So 4150 minus the margin of error is less than the population mean, which is less than 4150 plus the 205 dot dot dot. Okay? So for this one, I'm seeing a sample of 4 months. That's N, pretty small, isn't it? There's an average of 31 burglaries, and there's the standard deviation. So this is X bar, this is S. We're assuming the variable is normally distributed. That's the saving grace that allows us to do this, because the sample size of 4 is very small. So we've got the normal distribution, so we're good to go with the central limit theorem. I'm just noticing that I've got let's change this to 95. Okay, so the point estimate, again, I hope you realize by now that the point estimate is going to be this X bar of 31 burglaries. They want us to come up with a 95% confidence interval. I don't know what I did with the applet, if I did one with the applet. Tell you what, I'll just make sure I do this with the applet. So I'm going to encourage you to use the applet with this, folks, because if you don't, because this is about sample means, we have to use the t distribution for this. And using the t table, well, it adds a level of complexity. If you want to learn how to do that, I'm more than willing to show you how to do it, or there's plenty of videos out online to show you how to do it. But the applet really makes it pretty easy, and it's given us enough decimal places that I don't think MyOpenMath will bother by it. You just got to make sure you have the right level of confidence, and you type in your mean and your standard deviation right. It's unfortunate that this had the same sample size and standard deviation, but that's what it worked out to be. So that's the confidence interval, and that's just the interval. Remember, that's the lower bound, that's the upper bound. We're 95% confident the true mean number of burglaries will fall in that range. How do we find them? Let's see, what did I ask you next here? We did that. Oh, what's the margin of error? Well, I'm hoping you remember now that. How did we find that margin of error? We said subtract those two numbers. Get the answer, then divide by 2. And why don't I do that? Let's see here. $3,649 minus 24.635. I got 12.7299. I'm going to divide that by 2. That gave me 6.365 if I round to 3 decimal places. So that's my margin of error for this confidence interval for the sample. And we did that. So how do I write this with this inequality form? So the sample mean was 31 minus the margin of error. This has already had taken care of the level of confidence, so we don't have to double it or subtract it or anything. Double it or triple it or whatever. And we're dealing with the mean, and 31 plus the 6.365. So I hope that helps you do my open math.